Hello and welcome to the third video in the festive 7-inch quad build series. Thank you to those of you that have already left comments and got involved with this. Hopefully this is a little bit of fun. Now, as I've mentioned in the other two videos, this isn't really designed to be a how-to. This is me just using stuff that I've been sent for review and things out the spares bin, along with some motors and some other pieces that I've bought to build a 7-inch quad. Why 7-inch? Well, 7-inch allows us to kind of do some other testing, specifically around motor and prop combos, but also battery setups too. Initially, I'm setting this up of the 4S setup. That's why I'm using 1700 kV Emax motors and a 7-inch prop setup. But the cool thing is once this is built and all together, I don't have any issues at all kind of trying other motors, props and batteries stuff as well. Maybe lithium ion or maybe trying 6S and seeing what that does in terms of the current draw, the wattage that's used, and also the endurance that you can get out of something like this as well. Now, last time we pretty much got to the point where we managed to fire it up on mains power, confirm the GPS was working, confirm that the barrow weirdness that I was seeing was kind of sorted. This time, the aim for this video is a couple of things. First of all, is to configure the compass that's here at the back on the 3D printed mount that I've done at a nice 25-degree angle, show you the steps to get that done. Then we'll test the motors, make sure that works, and then we'll reverse. I guarantee there's at least going to be one, probably two. It always seems to work that way. They'll need reversing. This is an AM32 based ESC here from TBS, the Lucid 4-in-1 4S version. That is going to mean a slightly different set of tools, so I'll do it here. Might also make it as a separate video for those of us that are all bumping into more AM32 based ESC technology and are more used to things like BL Heli Suite. Then it's about doing things like fitting the Walksnail unit and getting that set up, and then finally hopefully we'll get to the end and we'll have it hovering. Next video then we can take it for a fly and just see what kind of currents it's pulling, the overall weight, where we end up, and what kind of efficiency and flight times I get out of a regular 1500 mAh 4S battery, and kind of do some calculations. And then from there on, when there are more things that we want to test, whether it's express ELRS receivers, different 7-inch motors and props, then I have this that we can stick them on. So if you have any recommendations for great setups in the 700 gram quad range that will give fantastic efficiency, not super bothered about having mega performance, hovering at about 40-45% throttle, I probably is going to be fine for a very gentle Explorer like this. But if you have any ideas, do stack them down below. So let's crack on back onto the desk. Let's first of all have a look at getting the compass set up, orientated correctly and calibrated. So the next thing we need to do on this is to complete all of the sensors. Now, we knew from last time that the GPS was working, the barometer was working, and the last thing we're going to need is the compass. Now, this little mount that I designed at the back is angled at a 25-degree, which is the most important thing we need to know. Just clears the ground, so that means that we can set that up. And we're going to have to set that up in iNav. Now, the thing for this is it's really handy to know where north is on your deck table. Now, I have a rough idea. It's kind of off here to the bottom and right of the image. So north is kind of in that direction, more or less the direction that it's pointing in. Now, the challenge with this is that, unfortunately, we have to power the flight controller from a battery in order to get this to work. Now, this is not something I'm particularly enamored about with the Lucid flight controllers. I do like the fact that SpeedyBee don't make you do that. So what I'm going to do, I'm going to plug it in. Remember, we did plug it in last time. It works fine. No props on for safety. But we're going to power it up first. And we're just going to let it settle and finish booting. And then what we'll do is we'll plug it into the computer, and I'll show you the steps to go through to enable the compass on something like this and to set up the alignment too, with it being a little bit custom. So we'll click on connect on the computer, and we can see here that we now have a full set of bits and pieces. The GPS, barometer, magnetometer is also on here as well. The way I got that to show was go into the configuration tab, and then here you can see it says magnetometer QMC 5883, probably something like this on your GPS. I just set it to auto, and then did a save and reboot, and it auto-discovered it. It auto-discovered it because I've connected the serial clock and the serial data lines, the I2C pins that's actually on the flight controller. We did that when we installed the compass. So once that comes back up, the magnetometer is there. However, we need to calibrate it. But before we actually go to calibration, we need to sort out the alignment. Now, this alignment tool is something that came in a couple of versions ago, and it is absolutely fantastic. Not only can we set the alignment of the flight controller if it isn't facing forward, which this flight controller is. How do I know it is? Well, if I go into the setup and I lift up the nose of the model, we can see the nose of the model, the bit with the arrow on, is rising on the screen. So that means the orientation is default. I don't have to worry about the flight controller. However, it is going to be the compass that I need to worry about because it is a weird angle. And if I just move all this around, there we go. This is how I've had to set it up. Now, what I would recommend you do is you just point the model towards north, the nose pointing towards north like I have it here, well, northish, and see what the readings are. I know that it has to be down at the back, and I had to just basically go through each of the orientations until I stumbled on one that then basically showed me that it seemed to be pointing in the right direction. If I go up here, you can see it tells me the heading, 357 degrees-ish, so it kind of knows it's pointing more or less in north direction. The key to know whether or not you've got the orientation of the compass is right, once you've kind of dialed in your guess, and all I'm doing was just try this red arrow in each of these orientations with that incline at the back. Click save and reboot, and then when you come back in here, if you lift the tail of the model, you should see the heading not change too much if it's in the right orientation. Changing a couple of degrees is fine, but you can see here as I move it up and down, that's absolutely tickety-boo. That means that you've actually got the compass in the right orientation. This orientation is a little bit weird from some of the others that I had. Again, this is a HGLRC compass that has got, these are really cheap and cheap from places like Banggood, but they actually work really nicely. And we can see here that that was it. So I've had to kind of move things around. This 155 degrees is 25 degrees off flat. So that's what it would have been like if it was flat. And it needs to be 155 degrees. I find if you just type the numbers in, that's 25 degrees less than 180. That seems to work absolutely fine. Now we know that that's okay, we can go into the calibration step, and then well away from all stray magnetic fields, click on calibrate compass while it's all still powered, and I would hold it all together, rotate it horizontally, rotate it with the nose to the ground, rotate it with one side to the ground. You get about 30 seconds, and at the end of it all, that is your compass done. Now, the compass is sorted, and while we've got it powered, we can actually check the direction of these motors, because I guarantee that at least one of these motors, probably two, is probably going to be completely unhappy. So let's make sure nothing is pressing against the bells when we turn everything on. Now the outputs are on, we had to do that last time. Again, props off for this, make sure that you're safe. If we go into the outputs, we can see there that we are good. Got the configuration for DShot 300, enable motor and servo output is on. If we look at the mixer, it'll show us the default setup. So that is 4, 2, 1, and 3. What I'm going to do is just grab a piece of paper to write that on. And this is my old school way of doing it. So it's 4, 2, 3, 1, and the direction they should be turning, because I guarantee some of these are going to be right and some of these are going to be wrong. So with that now down there, I can kind of just test each of these in turn. So what we're going to do is we'll go into the outputs. Well, first of all, make sure they all start okay. Again, just be super careful, make sure that everything is on. Don't use your props. We'll turn on the motor outputs and we'll raise the master. So that one's wrong, that one's right, That one's wrong, which means that one's probably right, and that one's right. Fab. Okay, so that's good. That's all working. That means that outputs 4 and outputs 1 are currently rotating in the wrong direction. That unfortunately means we're going to have to fire up some goodness and do the stuff with the AM32 tools rather than the BL Heli Suite, because this is an AM32 ESC. So let's do that bit next. So the cool thing with AM32 is that it's actually incredibly easy to do all the configuration. The only couple of things I've needed to do before I get into it is 2 things. Figure out how much kV I've got on these motors. It's 1700. Again, not convinced that's the best option for this. We'll fly it on that. Probably 13 or 1400 might have been a better bet. And I've also actually counted the number of poles. That's the number of magnets on the outside of the bell. And for most motors of this kind of size, 3 and 7 inch like this, it's going to be 14. I've just actually physically counted them and they are. So knowing that, we should be able to go in and reverse motors 4 and 1, which are going in the wrong direction, as well as set a couple of other pieces too. Now I'm going to put a link down below to a fantastic video that explains all the settings in AM32. I'm not going to go through everything in super detail, but I'll go through the stuff that I'm setting up for here. So we are going to have the ESCs powered again, so we'll power them up. And what we'll do is we'll also plug the flight controller into the computer. That is going to appear. So here on the computer, what we need to do is we can do it all through the browser. You can download a tool as well, but the browser is just so easy. You have to make sure you're using some form of browser that's going to work in. I found things like Firefox it doesn't like. With things like this is Edge, for example, it'll work fine. It has to be able to talk to the USB. So first of all, what we'll do is we'll click on port select. We'll click on the virtual COM port that we have connected to via the flight controller. If you were using something like Betaflight, you could actually just reverse the motors like I've shown in other videos just by kind of ticking on the boxes in Betaflight. As of this recording, that's not something we can do in iNav. And to be honest, if you're going to be playing with AM32, it's good to go in and tweak some of the settings anyway. So we're going to click on connect here in the top right hand corner, and we should see all this gubbins appear at the top where it's kind of looking at everything. And then when we click on configurator, if we click then read, which is in the top right hand corner, we should be able to see all of the data. Here it is coming through. So here we can see we actually have 4 motors appearing, and here's all the different settings. Now we have a couple of things that we need to change. Motors 4 and 1 need reversing. So motors 1 and motor 4, let's do those and then say just save that configuration. We'll see that those 2 are written. Again, I would go back and check it in iNav configurator. But while we're in here, there's a couple of things that I would probably go through. I would leave the protocol as auto. That means the AM32 stuff is just going to figure out what protocol it's being talked to via. This is DShot 300, so it's going to just figure that out. We want stuck motor protection on. The stuck motor protection means that if it gets stuck in a branch or where it lands and the motor prop gets stuck in a pile of mud, it isn't going to burn everything up trying to continue to run the motors, so that needs to be on. Stall protection isn't useful for multi-rotors, neither is use hall sensors because these motors don't. We want variable PWM and complementary PWM both turned on. Timing advance, I'd leave it the default of 15. Startup power, leave it at 100. Motor kV, I've set that to the actual kV of the motors, which is 1700. Motor poles is 14. Again, I physically counted what motor poles we have. On motors like this, it's going to be 14. On really small motors, it's going to be 12, but check the specs for the motors that you've got. Beeper volume is a default of 5. PWM frequency, we're going to leave it as the default, which is 24 to 48. I wouldn't go any lower than that for these, and we'll see how we get on. Turned off low voltage cutoff. I don't care about that, particularly if I'm going to try and fly lithium ion with this stuff. LVC needs to be off. Disabled both the temperature and the current limit because I want to be able to get this back to me in the event of something going wrong or me getting a little bit carried away. Sinusoidal startup is turned off. That's really more useful for things like crawlers and stuff, not any use on multi-rotors. Turned off brake on stop. We don't want it braking. That can be very handy for things like wings where you have an AM32 ESC. So when the throttle is at 0, then the motor is braked, and then once it's braked, it'll stop. Handy for things like folding props. Car type reverse braking, we've got that turned off as well. Just leave the reverse brake level at 10 and leave the servo settings alone, because we're not going to use any of the PWM control stuff. So with that all set, we should be good. So let's just triple check that that's fine. Let's make sure that we have everything saved into ESC 1 and 4, which we have. That's fab. Let's just go back into configurator and just check it's all working okay. And then if it is, we can do the Walksnail stuff. Now, the first thing I want to check is whether or not the Walksnail unit is actually physically still going to fit inside the frame. As we looked at the very beginning, it's going to be a little bit tight, and because of that, I've tried to mount everything at the bottom of the frame to give myself maximum clearage kind of in this space above. The good news is that it looks like this is actually going to work. So this is just a temporary Walksnail unit. I'm actually waiting for the real one to be delivered. This one is the Avatar HD Kit V2. I tend to use these dual antenna versions in planes, but actually a single antenna version is probably going to be absolutely fine for this. However, the main box itself is the right size. We'll come back onto the cable in a minute, but if I kind of just pop that roughly where it's going to be, it's going to go in the front, isn't it? Let me just move this around and pop the top deck on. Say that 4 times fast. Hopefully you can see there is absolutely shed loads of room in the back. I'm really pleased that we can do it. If I mount it at the top, then that is easily enough, trying to keep my fingers out of the way, it was a bit tricky, to go around everything. So I have a rough idea where I need to drill the holes in the top deck, because sadly the holes that are on here aren't really going to work. They need to be a little bit further forward. So what I'm going to do is create a little template with the 20 by 20 spacing on it and drill into this, and I'm going to have to cut out some of this pad at the top. Hopefully, if you're watching this Armatan, I would probably recommend putting, like you have on the bottom, both sets of mounting. It would be quite useful. And then it's just a case of routing the cable along the top for the camera. Now the big question is this Lucid Pro flight controller going to be okay with Walksnail? Now, some of the very early versions, I'd had reports and heard from patrons of mine that they were really struggling. And the cable that comes with it, that actually goes in the back of the flight controller, is designed to really plug into an O3 air unit. And I think that's because TBS actually like the GGI stuff and don't like the Walksnail stuff. However, the really exciting part is the actual pins in this cable are exactly the same as the ones that Walksnail use. So by sheer fluke, the stuff that is in the O3 air unit and the Walksnail system are now the same. So that now means that I've just repinned using a spare connector. We could have used the one that came with the Walksnail kit, and that means that I can plug this into the side. It's going to provide the 9 volts and ground. There is a little solderable bridge on the flight controller for which is which. 9 volts is a great option for these. 9 volts and ground, and the transmit pin on this little output to the receive pin, vice versa. I have also removed the ground and S-bus pins from this just to keep everything neat. But that means that this cable that was provided with the flight controller is actually going to work beautifully for Walksnail too. But we're going to need to power it and see whether that's the case, because although TBS absolutely assure me that this is all fixed now with this latest incarnation of the flight controller, I just want to double check it before I put it all together. So let me just wait until the actual final version of this comes in. Hopefully it'll be here in a day or two. Let's plug it into here, bind it to the goggles, and see if we have an on-screen display. I really hope so, because if we do, then all it's a case of is just designing the antenna mount at the back for the single antenna that will be part of that Walksnail unit, and also hold these 2 antennas vertically, or well, an angle actually, for the diversity system, and also have these holes drilled in the top, so this will fit beautifully underneath here, well out of the way of everything else. So hopefully that unit will be here in another day or two. As I'm recording this on New Year's Day, I've ordered it, but I guess we've got to wait everyone to get back to work in order to put it in the post. Just thinking about this, I can do something while I'm waiting for the new Walksnail unit to arrive, and that's to design something to hold both these two antennas in place, give me enough room for this cable to come through, but also have some kind of mount or support for the single antenna that's going to be part of the Walksnail system. Now ideally, I want the antennas to be at an angle, so they're not both vertical, they're both at a slight angle. That will give me the best possible chance of reception, and then have the antenna for the Walksnail unit just shooting straight up. I also want them tilted slightly backwards, and then that way, as it's flying around, these are kind of pointing straight up in the air, and the antenna on the radio can be too, for the best possible antenna alignment. Now I have designed it so that this little piece here at the top, I hope you can see that on the camera if I move the antennas out of the way. You can see here that there is this kind of flat. The idea is something can come out here and then have some kind of tree arrangement that's going to hold everything in place. So I've had a couple of goes. I do love 3D printing. Do check out my series on 3D printing if you're not into it in the hobby. When you're playing with stuff like this, it's worth its weight in gold. This was my first attempt. Looks like some kind of Gothic cross, but actually the idea with this is that it's going to kind of go at an angle, and then these antennas could kind of fit in it. However, once I printed this first one and had a go, I realized I could dramatically improve this and make it a lot better. And this is the way 3D printing tends to work. You tend to have one, which is your first kind of concept. This is the one that we're actually going to use. This is a slightly different one. Has kind of little claws to hold the antennas on. So the way this works is that these antennas will just kind of push into these two pieces at the side. And we're certainly going to use just a dab of glue. So that then gives me that slightly V configuration, and it's going to kind of need to go and tilt backwards. There is this channel that the antenna for the Walksnail unit can sit in. I can just put a cable tie around it to secure it. The other part then is there needs to be a little adapter to hold it on. Again, another little 3D printed piece here that's been designed for that very purpose. So the way this works is this is going to go and fit into there. It's a nice tight fit. Bit of CA is going to hold that in place, and then this kind of tree arrangement is kind of going to slide in there, again held in place with CA, and then that is going to be my kind of antenna array at the back with the Walksnail stuff out the top as well. Well out the way of the props. I have triple checked that when the props are moving around, even when they deflect under hard acceleration, they're going to get nowhere near these antennas. So I just thought that was quite a fun thing. Hopefully, I've had notification that the Walksnail unit's been shipped from Drone Authority. Hopefully it'll be here in a couple of days and we can finish off that Walksnail setup and check it's going to work. So back to the desk a couple of days later. Thank you to Drone Authority for getting this pretty quick to me. It's just arrived and I have unboxed it. This is the Avatar HD Kit V2. This is what it looks like. It's a single antenna setup and easily going to fit in this body. However, I have done a couple of things before we get too far into this. First of all is I have drilled some additional holes in this top deck using a 20mm spacing. The way I did this is I just printed out a little template, designed it on good old SketchUp, printed it out, and it helped me kind of figure out where it would fit, because obviously I don't want the holes too close to the other ones because I need a bit of space. The other thing that presented a problem then, of course, is that means that unfortunately the battery pad thing needed cutting away. Tried to figure out how to do that neatly, tried to do it with a very, very sharp X-Acto. It's not going to win any awards, but that should work absolutely fine. So that will allow me to mount it on underneath like that, and as we looked at before, that should work fine. So with that done, I have powered this up using the bench power supply, made sure I could link to the goggles so it's all working. That was great. So I've updated it to the same version that I've got in my Walksnail goggles. So then that's all fine as well. So we know that this bit is working. The next job then is to plug it in and get this tested to see if we've got an on-screen display. A couple of things about this. First and foremost is that I actually just tested that it was outputting 9 volts. There is a little a bridgeable solder joint on the flight controller, whether or not it's battery voltage or 9 volts. So I've set mine for 9 volts and I've tested it is 9 volts because that's going to make this a little bit happier. The other thing that I noticed, I was just triple checking that I had the wires the right way round, and I found this little note in the manual, and I'm very, very pleased that I did. These are the kind of things that should be in big capital letters, not hidden away on one of the pages, but you have to transfer the transmit and receive pin. You have to swap them over if you're using iNav. A little bit weird, but I'm glad I've spotted that, because that potentially would have caused me to have a bit of a freak out. So what we're going to do is I'm going to turn on my goggles. We shall plug in the avatar unit. I just want to make sure this is all going to work, that the on-screen display appears, because if it does, then it's just a case of physically installing this thing. Let me power it from a battery. And I'm not sure if you're going to be able to see this. Hopefully you can. We have an on-screen display. Hooray! The camera's on its side, so I'm going to have to make sure that that goes on the right way. But there is an OSD, so that absolutely works. So maybe that was part of the problem with some people historically. Maybe that's been changed in iNav, but you have to kind of turn those two things around. Now I know that that works. I'll turn the goggles off. It's just a case of putting this all back together. This isn't actually on, so if this motor had started, it was safe, so don't worry about that. Again, whenever you're plugging it in, don't put your props on. It's just common sense. So what I need to do now is screw this into the top. I might put a little spacer just to help with airflow. Got to install the camera into this front section, and then I'm going to have to just stick the antenna in this rear upward piece using a couple of cable ties. So let me do that, and we'll come back and we'll look at it all buttoned up, ready to take to the field. So after probably 2.5 weeks of building on and off, this one took a little bit longer because I was taking my time and I was kind of getting all the bits and pieces really. It actually started probably in early December. It's nice to finally have it all put together. The props are on. A couple of things to mention about before we get into the next video, where I think it's about time we take this thing out and give it a fly. First of all is how it's gone together. You can see here, hopefully, that there has been easily enough room for all the different pieces. I haven't had to really worry. The whole thing about the Walksnail stuff, there is enough room by mounting it on that top deck. So that little modification has worked out really nicely. Everything else has kind of gone together. I might still put a cable tie around this just to stop it vibrating. That's that little capacitor. I've put a couple of cable ties around the various bits and pieces at the back, and then we have the stuff. It's all gone actually together quite nicely. It is a little bit more compact in terms of the middle pieces than the Speedy one I did last year, but actually it's actually okay. Overall weight, where did it end up? Well, in the very first video, you may remember that I talked about the estimated weight was about 700 grams, and that's what I was using for all the thrust calculation. This, with this battery that I've got on top, this is one of the lighter batteries, but this is the one I was thinking about when I was weighing it all out. It's 5 grams underweight, so it's 695 grams, so 5 grams under the predicted 700 gram limit. I love it when that happens. Occasionally I get it right, occasionally it's a bit over, a bit under, but if I'd like to be a little bit under, but it's not an awful difference, but that should work fine. I'm probably going to balance the props. When you start to get more than kind of 5-inch, 6-inch props, it pays to balance them, so I'm probably going to take these off, put them on a balancer. They're actually slightly clear purple, actually. They look black, but I can see they're slightly purple. I will probably balance them. Dynamic balancing is probably better, just run each of the motors and kind of balance them all out, but I will just have a quick go at trying to do that just to minimize the vibrations. That potentially is going to help things like the IMU and other bits and bobs, and also camera vibration too. The only thing that I can't get working yet is the buzzer, the Vifly buzzer that's here at the front. Although it is powered, and I can see the green light, so it is getting battery voltage, when the battery is unplugged, it should start to beep. And also by flicking the buzzer mode switch, it should beep as well. All that happens at the moment, flicking the buzzer, just testing it here, is the motors make a nice loud beep. At the moment, it's the standard default volume as per the AM32 stuff that we set up. But that buzzer isn't making a sound. So we'll see what that's about. That might involve a little bit more messing about. If any of you watching the video have a little tip for how to get that working, please let me know. So next video then is to actually take this out, give it a fly, probably recalibrate the compass before I do that, balance the props, take it for a fly, see how it behaves. Also do things like check the hover throttle and then see where we're at. And now this can be a great 7-inch model that we can mess around, potentially replace the motors and props and do some testing of it as well for those of you that are interested in the bigger stuff. Thank you so much for watching the series so far. Hopefully that's been interesting. This one has definitely been more of a me kind of figuring stuff out. It's been a new frame I've never built before. It's a new flight controller that I've never put inside a quad. So some of it has been a bit of a learning experience, but hopefully following along, you'll now know that some of the things that might happen to you aren't unusual. They happen to us all. So join me in the next video where we get out to the field and we'll take it for a fly and see how it does. Thank you for watching my video. Check out the playlist, and adding Pedantry 60 to your search terms will help you find my content. If you haven't done so already, please hit the like and subscribe button. It helps a lot. You can support the time I spend here answering questions and helping others by using the links in the video description.